Okay, so we're looking at question 9 from the 2012 exam. Okay, so by introducing slack variables and artificial variables as appropriate, and using the big M method, we aim to write down the first tableau of the simplex algorithm down here for the following LP problem given here. And finally, we will then circle the entry that we would pivot on after we fill out the tableau. And we'll make sure not to forget this, because if you know what you're doing here, it's pretty much free marks. Okay, so the first thing to look at when we're doing a big M method problem or a two-phase method problem is to introduce slack variables and artificial variables to get these greater than or equal to signs or less than or equal to signs into equal signs. Okay, so let's go ahead and do that for the first constraint here. Okay, so we have 2x minus 4y, and now to get rid of this sign and make it an equal sign, because it's greater than or equal to, we'll need both a slack variable and an artificial variable to make this happen. So because we need both, we need to add a coefficient of -1 in front of our slack variable s1, and then we give ourselves an artificial variable, and then make that an equal sign, and then write 4. Okay, for the next constraint, we only have a less than or equal to sign, so we only need a slack variable to make that an equal sign. So let's do that. So we have 5x minus 3y, and then we plus our second slack variable, and then give ourselves equals 5. Okay, and finally, for the last constraint, we have 9x plus 11y, and similarly to the top constraint, we have a greater than or equal to sign here, so we do a similar thing to what we did here. So we go minus s3 plus r2, which is our second artificial variable, and then equals 3. Okay, so now that we've rewritten our constraints, we can then move on by using our big M method, and what it does is that it drives out our two artificial variables by making it an unfavourable part of z, and z being the objective function. Okay, so let's do that, and it'll become more clear once I write out our new objective function. So we still have z being equal to 6x plus 7y, but also we'll add our m, where m is large and positive, and then multiplying that by r1 plus r2, and this part just depends on how many artificial variables you have, and then putting a minus sign in front of it, which makes it an unfavourable part of the objective function which we aim to maximise. Okay, so now what we do is rewrite z, substituting r1 and r2 in. So how we do that is rearrange constraint 1 and 3 to make r1 and r2 the subject respectively, and chuck them in here, and that equals the following. Okay, so now we're ready to start filling in our tableau. Okay, so I'll just quickly add in the variables now. Okay, so we're ready to start filling in our tableau. Now the first row, which will correspond to the first constraint up here, so the coefficient in front of x is 2, in front of y is -4, in front of s1 is -1, and then zeros for s2 and s3 as they don't appear here, and then we have a 1 for r1 and 0 for r2, and then we have 4 at the end here. Okay, for the second row, we use the second constraint here, so a bit quicker this time. We have 5, -3, 0, 1, 0, 0, 0, and then 5. And for the final row, we have the third constraint. So we have 9, 11, 0, 0, -1, 0, 1, and 3. Okay, so we can quickly add in this first column here what our basic variables are. So in this case we have R1, S2, and R2. Alright, so it remains to fill in our final Z row here, and we do that like any other LP problem, but notice that we also have to add in the M parts down here as well. So firstly I'll show you what we do for the X column here. So again we have -6, and because we have plus 11mx up here, we have minus 11m down here. Okay, and similarly for the y, we have -7, and because we have plus 7my, we have minus 7m down here. Now for S1, we have minus m S1, so that gives us m. S2 doesn't make an appearance, and for S3 it's the same as S1, and then R1 and R2 don't make an appearance either. And then finally, for the constant at the end, we have minus 7m. Okay, so now we've finished our tableau, which is great, but there's one last thing we have to do, and that is circle the entry that would pivot on. Okay, so firstly, we have to find the most negative number in this Z row, and now remembering that m is large and positive, the way we find the most negative number here is to find where m has the most negative coefficient in front of it, and in this case we have minus 11m when compared to minus 7m is more negative. So this is the column we'll be looking at, and now we have to look at the ratios 4:2, 5:5, and 3:9, and find the ratio that is the least non-negative ratio, and in this case that is 3:9. So our pivot element will be this entry of 9 here. Okay, and that's it for this question.